is for a sample quiz problem. Hang on, Jack. So 27, if you were given just a graph like this, and you had to find the dimensions and the area. So the area and dimensions of the following rectangles. Sample quiz would be find the dimension and the area of the following rectangles, and let's say I start with rectangle B on that graph over there. So I'm going to have to get a rectangle in my head here. Well, that's okay. We're just trying to show you, like, let's pretend this is a sample quiz question, okay? And I'm looking at B. How would you do that, Jack?
So you would, in what Lindsay said, so you would look at B and then see what the length of B is, so that you see the point, and then you look down to where
Okay.
the point is.
Good start. So let's make sure everybody can catch up with you. So find point B on the graph, and the first number is the length. So if you bring this straight down, you can check to make sure the length is 2. Okay? It tells you the perimeter is 34. And the reason, I'm going to zoom in here, the reason the coordinates handy is because 34 isn't exactly on a line. But then he said, like Lindsay did yesterday, so what else did she do?
And then you look across the graph to see the next point that's even with the first point, which is point B.
He found the other point that also had the same perimeter and drops down, but also you could read the coordinate, that's 15. You see that? And it hits between 14 and 16, so 15's right there. Okay? So how is that helpful? Hang on, Lindsay.
And so
what do you know then?
Then so you have your 2 dimensions,
Which are
2 and 15.
2 and 15, and then we should check our work.
And then you multiply the
And yeah, and before I would do that, I would check to make sure the perimeter really is 34. 2 plus 15, 17. 17 plus 17 is 34. So the perimeter is correct. And then you know area is length times width. So it's 2 by 15. So the area is 30 meters squared. And that's how you could do that. Lindsay?
Another way to find the area
Yes.
is to look at the one and then the matching.
Really good. If you can find the one, whatever it pairs up with is the area of every rectangle on this.
I get it.
So smart. Look, so let's do it again. I'm going to get rid of all the yellows, okay? Because it's a lot of stuff to look at, and we're going to do the same thing with one more problem. So we're going to test out Lindsay's theory. Let's do graph D. Okay? She's saying if you can find the one on the, if this was a length versus perimeter table graph, if you could find the coordinate of one and then project over to the other coordinate, that other x value is the area of every single rectangle here. Okay, so let's test her theory. If I do this for rectangle G, or D, I'm going to zoom in. For D, I'm going to look at the length, and it is 5. And I don't have that point there, should have it. And if I project over, it's the same height as this other coordinate. The perimeter's 22. Can you see those numbers at all back there? Is it too small? And then according to this method of Lindsay's, it should be a 5 by 6. Okay, so we'll go to 2 pages. Test it out. So she says, if this is 5 and this is 6, first of all, I want to make sure that my perimeter matches with the graph. 5 plus 6 makes 11. 11 plus 11 make 22. Okay? And the area is length times width, and it's 30. 30 square meters. So if you can find that one coordinate and find its partner, it's going to tell you the area. So I'm going to just record that. That's a good little mini quiz question.
30.